Imagine your immune system as a massive army, millions of microscopic soldiers constantly protecting your body from viruses, bacteria, and disease. Every second, immune cells patrol your bloodstream looking for invaders. But what if this army suddenly lost its weapons, its communication system, and its ability to fight? That's exactly what happens when the body lacks a single critical nutrient, zinc. Despite being required in tiny amounts, zinc plays a massive role in human health. It's involved in over 300 enzyme reactions in the body and supports everything from wound healing to DNA repair. But perhaps its most important role is in immune function. Yet zinc deficiency is far more common than most people realize. Globally, researchers estimate that nearly 2 billion people may not be getting enough zinc in their diets. Even in developed countries, mild deficiency can occur due to poor dietary choices, aging, digestive disorders, or diets heavy in ultra-processed foods. And when zinc levels drop, the immune system begins to struggle. Let's explore why. The immune system depends heavily on zinc for the development and activation of immune cells. Zinc acts almost like a molecular switch that turns immune responses on and off. One of the most important immune cells affected by zinc is the T cell. T cells are responsible for identifying infected cells and coordinating the immune response. They help the body recognize viruses, activate other immune cells, and destroy infected tissues. Without enough zinc, T cell production drops dramatically. Studies have shown that even mild zinc deficiency can shrink the thymus gland, the organ where T cells mature. When the thymus shrinks, the body produces fewer immune cells, leaving the immune system weakened and slower to respond to infections. This means viruses and bacteria gain a much easier foothold in the body. But zinc's role doesn't stop there. Zinc is also essential for the function of natural killer cells, one of the immune system's first lines of defense. These cells patrol the body looking for virus, infected or cancerous cells, and destroy them before they can spread. When zinc levels fall, the activity of natural killer cells drops significantly. In practical terms, that means the body becomes slower at recognizing dangerous cells. Research has shown that people with zinc deficiency may experience longer illnesses, more frequent infections, and slower recovery times. Respiratory infections, in particular, appear to be affected. In fact, zinc has been widely studied for its potential role in reducing the duration of the common cold. Several clinical trials suggest that zinc lozenges taken early in a cold may shorten symptoms by interfering with viral replication and boosting immune responses. But prevention may be even more important than treatment. Another fascinating role of zinc is its involvement in immune signaling. When pathogens enter the body, immune cells release chemical messengers called cytokines. These molecules help coordinate the immune attack by directing cells where to go and what to do. Zinc helps regulate this communication network. Without enough zinc, cytokine signaling becomes disorganized. The immune system may become either underactive, failing to fight infection effectively, or overactive, producing excessive inflammation. This imbalance can have serious consequences. Too little immune activity increases susceptibility to infections. Too much inflammatory activity, on the other hand, can damage healthy tissues and contribute to chronic diseases. Researchers have even found links between low zinc levels and higher levels of systemic inflammation, a risk factor for conditions such as heart disease, metabolic disorders, and autoimmune diseases. In other words, zinc helps keep the immune system balanced. Zinc also plays a crucial role in maintaining the body's physical barriers against infection. The skin and mucosal linings of the respiratory and digestive tracts act as the first line of defense against invading microbes. Zinc supports the integrity of these barriers by promoting cell growth, tissue repair, and wound healing. That's why zinc deficiency can lead to delayed wound healing, skin lesions, and impaired tissue repair. Inside the gut, zinc also helps maintain the health of the intestinal lining. A weakened gut barrier may allow harmful microbes or toxins to enter the bloodstream more easily, triggering inflammation and immune activation. So zinc supports immunity both inside and outside the immune system itself. But who is most at risk for zinc deficiency? One group is older adults. As people age, the body becomes less efficient at absorbing nutrients. Appetite may decrease, diets may become less diverse, and medications can interfere with nutrient metabolism. Studies show that many older adults consume less than the recommended amount of zinc. This may partially explain why immune function often declines with age. Another group at risk includes individuals with digestive disorders, such as inflammatory bowel disease or chronic diarrhea, where nutrient absorption can be impaired. People following extremely restricted diets may also struggle to obtain enough zinc if their food choices lack variety. And then there's the impact of modern processed diets. Highly refined foods tend to be lower in essential minerals like zinc compared to whole foods. When diets shift toward refined grains, sugary snacks, and fast foods, the body may receive fewer of the micronutrients required for immune resilience. But here's where things get interesting. Many of the healthiest whole plant foods contain zinc, often packaged alongside fiber, antioxidants, and anti-inflammatory compounds that support overall immune health. Some of the best plant sources include beans, lentils, chickpeas, pumpkin seeds, hemp seeds, cashews, oats, and whole grains. A single handful of pumpkin seeds, for example, can provide a significant portion of daily zinc needs. Legumes such as lentils and chickpeas also offer a powerful combination of plant protein, minerals, and fiber that nourish both the immune system and the gut microbiome. And that's important because the gut microbiome itself plays a major role in immune regulation. However, plant foods also contain compounds called phytates, which can bind minerals like zinc and slightly reduce absorption. But traditional food preparation methods, such as soaking, sprouting, fermenting, and cooking, can significantly improve mineral availability. For example, soaking beans overnight before cooking can help reduce phytates and enhance zinc absorption. Fermented foods like sourdough bread may also increase mineral bioavailability compared with refined white bread. In other words, traditional food practices often solved these nutritional challenges long before modern science explained them. Now, what about zinc supplements? While supplements can be useful in certain cases, such as diagnosed deficiency or increased needs, more is not always better. Excessive zinc intake can interfere with the absorption of other important minerals, particularly copper. Long-term high doses of zinc may actually suppress immune function rather than enhance it. For most people, focusing on a balanced whole food diet is the safest and most sustainable approach. And it's not just about zinc alone. Nutrients like vitamin C, vitamin D, selenium, iron, and plant antioxidants all interact within complex biological systems that support immunity. No single nutrient acts in isolation. One of the most fascinating discoveries in nutritional immunology is how micronutrients influence gene expression within immune cells. Zinc acts as a structural component of proteins called zinc finger transcription factors, which regulate how genes are turned on and off. These proteins control processes like immune cell development, inflammation, and DNA repair. Without sufficient zinc, these genetic regulatory systems can malfunction, impairing the immune response at the most fundamental biological level. So zinc isn't just another mineral, it's a key player in the molecular architecture of immunity. But nutrition is only one piece of the immune health puzzle. Sleep, physical activity, stress levels, and overall diet quality all influence immune resilience. Chronic stress, for example, can increase inflammatory markers and suppress immune cell activity. Poor sleep can reduce antibody production and increase susceptibility to infections. Regular physical activity, on the other hand, improves immune circulation and reduces chronic inflammation. When combined with a nutrient-dense diet rich in whole plant foods, these lifestyle factors can dramatically improve immune function. So what does an immune, supportive day of eating look like? Imagine starting your morning with a bowl of oatmeal topped with pumpkin seeds, walnuts, and berries, a combination rich in zinc, fiber, and antioxidants. Lunch could include a hearty lentil and vegetable soup alongside whole grain bread. Dinner might feature chickpea and spinach curry with brown rice, delivering plant protein, minerals, and anti-inflammatory phytonutrients. Snacks like cashews, hummus with vegetables, or roasted chickpeas can further boost nutrient intake. This kind of dietary pattern provides not only zinc, but a wide array of immune, supporting nutrients working together. The takeaway message is simple yet powerful. A tiny mineral measured in milligrams can have enormous effects on the immune system. Zinc helps develop immune cells, regulate inflammation, support physical barriers against pathogens, and even control gene expression within immune tissues. When zinc intake is inadequate, the immune system becomes weaker, slower, and less coordinated. But by prioritizing whole, minimally processed foods, especially legumes, seeds, nuts, and whole grains, we can supply the body with the nutrients it needs to defend itself effectively. Because sometimes the difference between a resilient immune system and a vulnerable one comes down to something as small as a trace mineral on your plate. Zinc plays a fundamental role in the proper functioning of the immune system because it is directly involved in the development, maturation, and activation of many types of immune cells. Among the most important of these are T cells and natural killer cells, which serve as essential defenders against infections and abnormal cell growth in the body. Without adequate zinc, the immune system cannot produce or activate these cells efficiently, leaving the body less prepared to respond to threats. T cells are a critical part of the adaptive immune system. They help the body recognize and respond to specific pathogens such as viruses and harmful bacteria. These cells are produced in the bone marrow and mature in an organ called the thymus. Zinc is necessary for the proper development of the thymus and for the maturation process that allows T cells to become fully functional. When zinc levels are low, the thymus gland can shrink and produce fewer T cells. As a result, the body's ability to identify and attack invading microbes becomes weaker and slower. In addition to T cells, zinc is also essential for the activity of natural killer cells. These immune cells belong to the body's innate immune system and act as one of the first lines of defense against infection. Natural killer cells constantly patrol the body, looking for cells that have been infected by viruses or have become abnormal, such as cancerous cells. Once they detect these dangerous cells, they destroy them before the problem spreads. Zinc helps regulate the signals that activate natural killer cells and enhances their ability to perform this surveillance role. When zinc intake is inadequate, the activity and efficiency of these cells can decline significantly. This means infected or damaged cells may remain in the body longer, increasing the risk of illness. In this way, zinc acts almost like a critical fuel for the immune system, supporting the creation and performance of the very cells responsible for protecting the body from disease. Even a mild deficiency of zinc can have noticeable effects on the body's ability to defend itself against illness. Because zinc is involved in the growth and activity of many immune cells, insufficient levels can slow down the production and performance of these protective cells. When the immune system cannot produce enough of them, or when they function less efficiently, the body becomes more vulnerable to infections and disease. One of the earliest consequences of low zinc levels is a reduction in the production of key immune cells, such as lymphocytes. These cells are responsible for identifying harmful pathogens like viruses and bacteria and coordinating the immune response. When zinc is lacking, the body produces fewer lymphocytes, which means the immune system's response to invading microbes becomes weaker and less organized. As a result, pathogens that might normally be eliminated quickly can remain in the body for longer periods. This can lead to infections occurring more frequently. People with low zinc intake may notice they catch colds, respiratory infections, or other illnesses more often than usual. Their immune systems may simply not be responding with the same speed and strength as they would with adequate zinc levels. Another important effect of zinc deficiency is slower recovery from illness. Zinc plays a role in tissue repair, cell regeneration, and inflammation control. When zinc levels are insufficient, the body's healing processes can slow down. This means infections may last longer, symptoms may persist for extended periods, and the body may take more time to return to full health after being sick. Research has also shown that zinc deficiency can increase the severity of certain infections, particularly those affecting the respiratory system. In such cases, the immune system struggles to control the spread of pathogens effectively. For these reasons, even a mild shortage of zinc can gradually weaken the body's defenses, making individuals more susceptible to repeated infections, prolonged illness, and slower overall recovery. Zinc plays a critical regulatory role in the immune system by helping control signaling molecules known as cytokines. Cytokines are small proteins released by immune cells that act as messengers, allowing immune cells to communicate with one another during an immune response. When the body detects a virus, bacterium, or other harmful pathogen, cytokines signal immune cells to move to the affected area, activate defense mechanisms, and coordinate the attack against the invader. For this communication system to function properly, the body needs balanced cytokine activity, and zinc helps maintain that balance. When zinc levels are adequate, cytokine production and signaling remain well regulated. This allows the immune system to respond quickly and effectively to infections without causing unnecessary damage to the body's own tissues. Zinc supports the proper functioning of immune cells such as macrophages, neutrophils, and T cells, all of which release cytokines to guide the immune response. In this way, zinc helps ensure that immune signals are sent at the right time and in the correct amount. However, when the body lacks sufficient zinc, this delicate signaling system can become disrupted. One possible outcome is a weakened immune response. Without proper cytokine signaling, immune cells may fail to activate quickly or coordinate their actions efficiently, allowing infections to spread more easily in the body. The immune system may simply respond too slowly or too weakly to eliminate pathogens effectively. On the other hand, zinc deficiency can also lead to excessive production of inflammatory cytokines. This can trigger an overactive immune response, causing chronic inflammation. While inflammation is a natural part of the body's defense system, excessive or prolonged inflammation can damage healthy tissues and contribute to various chronic diseases. By regulating cytokine activity, zinc helps the immune system maintain the right balance, strong enough to fight infections, but controlled enough to prevent unnecessary inflammation and tissue damage. Zinc plays an important role in maintaining the integrity of the body's physical barriers, which serve as the first line of defense against harmful pathogens. Before the immune system even needs to fight an infection internally, the body relies on protective surfaces such as the skin, the lining of the digestive tract, and the respiratory system to block viruses, bacteria, and other microbes from entering the body. Zinc supports the health and strength of these protective barriers by promoting proper cell growth, repair, and regeneration. The skin is the body's largest protective barrier, constantly shielding internal tissues from the external environment. Zinc helps maintain the structure and function of skin cells by supporting collagen production, cell division, and tissue repair. When zinc levels are sufficient, the skin can heal more efficiently from cuts, wounds, or irritation. However, when zinc is deficient, the skin's ability to repair itself becomes weaker, which can lead to delayed wound healing, skin irritation, and increased susceptibility to infections. Zinc is also vital for the health of the gastrointestinal lining. The gut lining acts as a protective wall that allows nutrients to pass into the bloodstream while preventing harmful bacteria, toxins, and pathogens from entering the body. Zinc helps maintain tight junctions between intestinal cells, which keep this barrier strong and intact. When zinc levels are low, the gut barrier can become compromised, making it easier for harmful substances to leak into the bloodstream and trigger inflammation or immune reactions. In the respiratory system, zinc supports the health of the mucosal lining in the nose, throat, and lungs. These tissues produce mucus and other protective substances that trap and remove pathogens before they reach deeper tissues. By helping maintain healthy respiratory cells, zinc strengthens the body's natural defenses against airborne infections such as colds, flu, and other respiratory illnesses. Maintaining adequate zinc levels does not necessarily require supplements for most people, because many everyday whole foods naturally provide this important mineral. A variety of plant-based foods such as lentils, chickpeas, pumpkin seeds, nuts, oats, and whole grains contain meaningful amounts of zinc and can contribute to a strong and resilient immune system when included regularly in the diet. Legumes like lentils and chickpeas are among the most nutritious plant foods available. In addition to providing zinc, they supply protein, fiber, and a range of vitamins and minerals that support immune health. Fiber from legumes also nourishes beneficial gut bacteria, which play an important role in regulating the immune system. A healthy gut microbiome helps the body respond more effectively to infections and inflammation. Pumpkin seeds are another excellent source of zinc. Even a small handful can provide a significant portion of the daily zinc requirement. These seeds also contain healthy fats, antioxidants, and magnesium, which further support overall health. Because they are easy to add to meals, pumpkin seeds can be sprinkled over oatmeal, salads, yogurt alternatives, or blended into smoothies. Nuts such as cashews and almonds also contribute to zinc intake while providing beneficial fats and plant protein. These nutrients help reduce inflammation and support cellular health throughout the body. Meanwhile, whole grains like oats, brown rice, and whole wheat provide zinc along with complex carbohydrates and fiber that help maintain steady energy levels and support digestive health. Including a variety of these foods throughout the day helps ensure consistent zinc intake while also delivering other immune-supporting nutrients. When these whole foods replace highly processed options, the body receives a broader spectrum of vitamins, minerals, antioxidants, and plant compounds that work together to strengthen immune function and promote long-term health.